What's up, homies? I was going to take another swing at explaining what I thought was interesting about that delayed choice quantum eraser experiment. Now that a day's gone by, and presumably my brain works a little somewhat more normally. So, the double slit experiment is just like a really fantastic starting point for exploring the quantum weirdness, I'd say. And it's one of the first experiments we can look to that just kind of blew our minds, and we still don't really have a way to explain what we're seeing. But essentially, you're firing very small particles that are so small that they operate at the quantum scale, you could say. And like you can imagine this being individual photons for just the purpose of argument, but we've actually repeated the experiment with larger, basically molecules. But anyway, if you could imagine there being like a really tiny slit in a screen, and on the other side of that screen you've got the detector, then if there's just the one slit, it would be like throwing softballs at a hole at some kind of an arcade game, and what you'd see is a build-up pattern on the other side on the screen, and that's exactly what they saw. So no surprises there. But when you introduce a second slit that is like super close by, there's rules about how close, and that has to do with essentially the wavelength of the particle. But it turns out they saw something kind of extraordinary, which was there was not two buildup patterns as you'd expect if you were just hurling baseballs at the thing. There was what seemed to look like an interference pattern that we see in other things in nature that have the wave nature to them. For instance, two ripples in a pond. You throw two rocks in a pond, and when the waves kind of develop, across time, when they hit each other, they interfere, and you'll see either constructive interference or destructive interference, in which case there's blank spots, and that's exactly what they saw. So, pointing to this wave nature, but then they took a close look through some very tricky experimental measures to basically observe which of the two slits that single photon, or whatever it is, passed through. And just doing this seemed to almost trick nature into behaving. And suddenly we didn't see a wave nature, we saw particle nature. And this was just mystifying, though, because it's like, why would it be the case that just like watching it, suddenly it's like nature is like, oh shit, he's watching, we better be deterministic about this, right? Whereas if no one was watching, and it's almost like if it could have passed through both slits, then we saw this probabilistic nature of the universe, fundamentally in the exact same experiment, where it's almost as if it passed through both slits at the same time and interfered with itself. How could a particle do that? So, as if that's not cool enough, later experiments, and there have been several to kind of push this classic experiment in new, interesting directions, but they basically found a way to have not a human observer observe which slit passed through, but instead basically set up, you can think of like a machine or a program to do that. And so programmatically, there's some mechanism that stores the which way information. So that could be known if you chose to look at it. And, but you can also imagine, like, if that information is then destroyed, then no one could ever see it, and it could never be known. So this is so interesting to me because it kind of crushes the most common, prosaic rebuttal of this, what's happening here with the so-called observer effect, which is that something maybe like the light particles themselves were incident off of the quantum particle, and it was that interference, that entanglement really with the outside world that collapsed the wave function, and that's what created that single deterministic outcome. But I think this pretty much conclusively shows that that's not the case, that that cannot be the case. And it seems to be more about the fundamental knownness of it. If the information is stitched into the collective mind, then it's happened either this way or that. Or, you know, if you take like a multiverse kind of ontological interpretation of quantum mechanics, you know, to the extent that scientists are even interested in making those, this has been proposed that, you know, every such this or that junction is essentially just a fork. And, you know, whatever particular realm with all of it, like the worldly specificities that we're currently existing in, that's really just one of many. So, all right, there you go. Peace.